Welcome back to the Glider Flight project. In this video, I'll cover what is a card deck, how do I read these test cards and communicate to the pilot behind me what test point I'm asking them to execute next, what type of information am I going to take down, what is the card even saying to the reader. So if you have a deck of cards, please make sure you get it, follow along, take notes as needed. So let's get started. The deck of cards we'll be using were created between a partnership agreement between Edwards Air Force Base and the Career Engineering and Design Academy. It's just for educational purposes. So typically you have a deck of cards distributed to a team so everyone knows what test plans will be executing. On one side of the deck, traditionally you'll have room to write information such as, hey, what's today's date when we're doing this test? What type of aircraft are we flying? So in this case, all the different types of gliders, make sure you write the specific glider you're using. Who's the pilot? That is very important later on when we analyze data, because sometimes the way maneuvers are executed will be a slightly different just because of the behavior the pilot is using to do certain maneuvers, the input they're giving the aircraft. As a flight test engineer, again, that's you. Make sure you write your name down. On the right side, typically you have a dance card. It pretty much outlines what test plans you'll be executing in what order. They'll get briefed in that order. It doesn't mean you have to execute them in that order, even though they might be in order of efficiency and safety. As long as you don't have a requirement to do a previous maneuver before the next one, you're fine. So what I mean by that is, if there is a requirement to do card 4 before you do, let's say, card 6, that means if you do not execute card 4, immediately you can do 6. But let's say card 3 is done and that's not a requirement to anything else, then you could have potentially put that card at the end. That's what I mean. So what do the cards say? What kind of information? Well, you have traditionally a section where it tells you, hey, what's the objective of this card? In this case, it's just an Instrumentation Start-Up card, which basically is trying to get your data acquisition system, which in this case, it's your cell phone with MATLAB Mobile, along with the camera that we'll be using to record the dashboard where all the instrumentation sensors are in front of the glider. You'll have a section of telling you, hey, what are the initial conditions before I execute the maneuver, the ones that they have to be. So for example, is it at a specific altitude, specific speed? Do I need to have the landing gear up, meaning inside the bay if you have gear that deploys? What are my limits for both the aircraft and the limits for the specific test, which are different? Aircraft limits are what are the maximum, let's say, speeds that you're allowed to execute in that aircraft, versus test limits are usually set by a team saying, hey, we will not go past a certain altitude in the series of all these test cards, for example. Then you have, again, what are your instrumentation and data requirements? What do I actually need to, as instrumentation, to collect all the information I need? And with that, you'll traditionally have your go and no goes. So that are specific things you need to make sure you get the information you need to stay safe. So in this case, let's say, hey, my sensor that reads speed is broken. I'm not going to go fly because I have no idea what the speed is when I'm flying. Then you'll have your data bands. That's traditionally for what you care. So example, in the next one, you'll see if there is a specific speed that I have to execute a test point and I have to stay within that speed, you'll have a data band of what you're expecting. So if it's a test point where you're just speeding up, it might say, hey, your test band for this test point is 100 knots to 200. And with that, you'll have a specific set of tolerance, meaning kind of the air you're willing to carry. So if your tolerance, if let's say you're doing a kind of minus 45 to 45 roll, then my tolerance could be potentially plus or minus 5 degrees. So that means if I was supposed to start at negative 45, now I could go plus or minus 5, which means I could start at negative 50 or negative 40. And as I roll to the right, I can stop at 40 or 50, and that's allowable within the area that I'm willing to execute a maneuver. Weather requirements, believe it or not, we do have those. For example, if you have a microphone sensor that has a little like membrane in it, um, if moisture gets in there and it freezes as water expands, it could fracture the sensor. So you sometimes might see, hey, avoid visual moisture, which just means avoid clouds because we don't want to break these sensors. So that's traditionally what you'll see in that section up here. Moving down, you'll have sections where it'll tell you, hey, here's your setup procedure, kind of some other information you might need to set up that test point. So in this case, it's saying, hey, the FTE, in this case, the flight test engineer, again, will be using acronyms, and the observer or the OBS should simultaneously press start on the MATLAB mobile and record on the GoPro. Again, the main reason behind that is if you're able to synchronize the information you're getting from the visual to then all the data that you're recording on your cell phone, you're able to then go back and see what the video was showing with what the data was recording at that point. So I'll give you an example. Let's say you're doing a wings level side slip, and for some reason you didn't get a number down when you were executing that test point. Now you could go back, watch the video, listen to yourself say wings level side slip on deck, executing in 3, 2, 1. You can use that timestamp of the video with a timestamp of the data recorder to go back and see, hey, what was my altitude, what was my ground speed, and so on, to capture some of that information you might have missed. So that's why it's important. So again, the setup procedure is just giving you some advice. On the right side, you'll actually have the procedures themselves. So in this case, hey, step 1, observer click record on the GoPro. Step 2, the FTE start on the MATLAB mobile app. But if you remember from the setup procedures, it says that these two should be done simultaneously for that reason. So again, even though it's not maybe clear here, on the left side it's telling you you should do that. And then step 3, it's saying, hey, again, if you didn't get that done, go back, try again. So stop anything that might have started and try to synchronize them again. And then step 4, if you are using a thermometer to look at the temperature, it's time to install it before you take off. So again, that's the typical layout of this deck of cards. If there are any acronyms like here, nautical miles, NM, visual flight rules, VFR, knots, ATS, they will all be initially defined, but later on in the test cards, just like the FTE, which was defined on the cover sheet, they will not be defined again. So the next card will be card 1. This one, the objective is to record the takeoff speed. So again, in this case, we're taking off, so the gear's down. Test limits, again, is just telling the pilot who's actually flying. For aircraft limits and test limits, make sure you stay within aircraft limits, in this case for the glider, whatever the manual says, and don't take off if winds aren't safe. So for example, go no go criteria is the crosswinds, which again are the winds coming perpendicular to the aircraft, must be less than 15 knots. Data bands and tolerance. So here, since we're asking you to record what the indicated airspeed in the dial is within an accuracy of plus or minus 5 knots, that is kind of, again, now a heads up, hey, I need you to get this number within this error. Local takeoff time, again, just carry a watch, make sure you write that time. And again, on the left side here, it's just telling you, hey, takeoff speed means when the glider's wheel or wheels are completely off the ground. So that will be a sense of yourself feeling that you're off the ground, because as you could tell, once you're in the glider, you probably can't see the wheel. And there's no indication or sensor letting you know, hey, the wheel's no longer touching. So that's how you're supposed to take that reading. Moving on to the next card. In this case, it's 2 alpha. So 2 alpha meaning there's probably a Bravo card, 2B. So you will only execute one of these two. You guys will decide as a team which group will do alpha, which group will do Bravo. Card alpha is trying to look at the accuracy of the software that you're using. Again, that's MATLAB Mobile on your cell phone device, using the internal sensors of your aircraft, of your cell phone, to try and see how accurate they are to the aircraft ratings. In this case, what you're trying to do, it's telling you you will try and record what the speeds were at specific altitudes. So in this case, the data band says it's going to be from 0 to 4,000 because you're being asked to take 4 readings once you take off, 1,000 feet above the ground, and every 1,000 thereafter until you reach 4,000 feet above the ground, which for the airport we'll be using will be equivalent to 8,200 feet mean sea level. Mean sea level basically is a reading from a mean reading of above the ground level of water. You'll be up about 4,200 feet, which will be equivalent to 0 feet above the ground, and from there on we'll go 4,000 feet higher. So the way that you'll execute this card is pretty much you'll look at the dial, which again we'll have different videos showing you how to read the gauges. And as you pass 1,000 feet, you have 2 options. One is the set of procedures letting you know, hey, you could tell the pilot to help you and say, hey, every 1,000 feet up to 4,000 feet our tow altitude, can you just say passing 1,000 feet every 1,000 feet until we get to 4K? 4K meaning 4,000. And if they say, yeah, that's fine, or say, no, that's your job, then you as an engineer will take those readings down and you'll have to read the dials. But let's say they say, yeah, sure, that's no problem, I'll do that. So the expectation as the procedure is saying, hey, pilot, as you pass 1,000 feet and every 1,000 feet after, please state passing 1,000 feet. Once they say that, it will be your job as you pass 1,000 to write down what the speed is and the time lapse. So meaning, let's say we take off, I write down what my takeoff speed from the previous card, and then the clock starts from there. So as I set my timer and I'm waiting for the pilot to say passing 1,000 feet, I will then say copy, passing 1,000 feet, or passing 5,200 feet, mean sea level, 60 knots, 10 seconds elapsed time. And then after that, the pilot will probably say passing 1,000 again, and I'll say copy, passing 2,000 feet above the ground level, 65 knots, and it's been, let's say, 30 seconds, and so on. Whatever you decide to say, either the 4,200 feet mean sea level and so on, or 1,000, 2,000, make sure you stay consistent with the unit of measurement you're going to be using. Towards the end, once you're done with step 5, it's your responsibility to let the pilot know you're done with the test point by saying test point complete. That just lets the pilot know we're done with this test card, we're moving on to the next one. So for example, let's say you're on 2 Bravo, and this one you can let the pilot know, hey, test card 2 Bravo on deck, temperature survey. And this one's similar to the first one. The difference is you're using that temperature probe that you might have if you're doing this test card, and you'll have it outside the window, the little wire, and you're just reading what the temperature is. So the importance of this card, more on the engineering side, is to give you an idea of how the temperature changes with altitude, which affects like the density of the temperature throughout the day. So you'll want to collect this in the morning, midday, evening, or every 30 minutes, whatever you guys decide, just to get an idea of how the temperature is changing across 4,000 feet in altitude across the time of day. So again, because you have the takeoff time of the first card along with this card, you'll be able to know, hey, at this temperature, these were the different readings in altitude and so on, and see how it changes over time. So for this card, again, it's saying, again, ask the pilot if they are willing to call every 1,000 feet. So again, let's say before takeoff, I write down the number and it was 73 degrees. As I'm passing 1,000 and I hear the pilot say 1,000 feet, copy, passing 1,000 feet above the ground level, temperature 60 degrees, and so on. And again, once you get to the last reading, test point complete, letting know the pilot you're complete with a deck with these test points, and moving on to the next card. So again, you'll say now card 3, wings level stall. Altitude must be greater than or equal to 2,000 feet above the ground. Airspeed greater than 50 knots. And then, as you can see here in the test procedure, it's telling the pilot exactly the same thing. So you could communicate to the pilot again what I just reiterated and said out loud. And then it's saying, okay, to start the test point, you'll say, set up wings level stall. That's letting them know, hey, set up for this maneuver. Once the pilot's on condition, you'll ask them to say, please say on conditions, and you'll say clear to maneuver. That means I'm ready for you to execute the maneuver, and I'm ready to understand what am I going to be reading as you're doing the maneuver so that I could write those numbers down. Because step 4 says, again, once you say clear to maneuver, it's telling you to monitor the altitude and airspeed because you're going to be writing those down. It then gives the pilot a sense of how slowly they should slow down to make sure you guys stall. And then again, it's asking the pilot to say stall so that in case you don't understand what that feeling is, because you're maybe on the glider for the first time, you know that's the trigger for you to write down the altitude and speed at the start of the stall. Click your recorder of your stopwatch and but keep track of the timer and then the recovered altitude and speed, and for you to write down. So with that said, again, let's go through the card as if I was reading it. And another good point to make now, I guess, is you're going to be in a glider with a knee pad on your foot, not on your foot, on your leg. And all the cards will be clipped on there with a pen that has a string attached to it. In case you let go of it, it doesn't go everywhere in the cockpit. So what I mean by that, if you look at the intro video that I showed you guys last time, you'll have a stopwatch in your hand. On your leg, you'll have a knee board with all your documentation and a pencil with a string. Again, the purpose there is to make sure that you do not lose anything and it becomes a FOD. FOD just meaning it's an object that can cause something to go wrong. For example, in this case, let's say your pen just flies back and hits the pilot in the eye, and now he's hurting from the eye. So it's you want to make sure you don't have stuff flying around when you're flying. So again, we're using the knee board. We're using the clip to keep your papers on it. You don't remove it from the clip, and you use your pen so that it's attached to the clipboard. So going back to this one, again, I would say setting up for wings level stall, greater than 2,000 feet, 50 knots. Please state when on condition. Pilot will say on conditions, and I'll go clear to maneuver, start my watch, and well, not yet. Don't start your watch. It says start your watch once you stall. And then when the pilot says stall, start, write down my altitude, my knots, and as he says recover, or she says recover, click. Again, what's my altitude, what's my speed, and what was the time lapse. And then once I'm done taking all that information, I'll let the pilot know test point complete. Now, you have the ability to redo the card in the event that caught you off guard and you didn't capture anything. You could always say can we execute this point or repeat? And you'll say, hey, can we repeat the wings level stall, please? And then they'll say yes if we have the altitude for it. Or if they say, hey, sorry, we got to move on, then you move on. But if you repeat, then that's just giving you another opportunity to go back and execute the test point again and try to get those numbers. But remember, you do have a recorder, video, and your phone to try and capture that information. But if you're trying to just understand how pilots execute test points and how test teams grab that information in that short time frame, and you just want to experience it again and try to do it within the time limit, then ask for a repeat. Learn from your mistakes that you did on the first one to try and to improve on that next one. Meaning, when you said, hey, clear to maneuver, and you really weren't ready because you didn't realize what the gauge was, what the speed it were currently, and saw them slow down and the altitude potentially decrease as he said or she said stall, then now the next time you're able to actually do that. So again, learning from your mistakes, improving on it by potentially saying repeat, but understand you have a certain number of cards that you're trying to get through. And depending on the speed of you going those and how many times you ask for repeats per card, which I would not recommend doing more than 3. And actually that will be a rule that we'll have. You will not be allowed to execute any of these cards more than 3 times. You might not get to the last card. And again, your objective is trying to get as much of the information you have in the time limit you have. So think about it. Okay, moving on. Card 4, this is a push-pull. A push-pull is pretty much, and I'll show you later on also with a simulator in different videos. A push-pull is having the aircraft kind of dipped out and then come back up. So for that, again, in this case, your data band, you're expecting to feel between 0 and 2 times G. A G means the gravitational pull that Earth has on you. So you sitting down watching this video, wherever you're at, you're feeling 1G. The equivalent of the Earth pulling on you, either 9.8 meters per second squared, or if you convert it into feet, about 32 feet per second. So you're going to experience 0G, meaning feeling like you're falling, to then feeling 2 times your weight. And again, the tolerance for this, since I'm asking you guys to record the load in G, your normal acceleration, to then your starting and ending altitude, I need you to grab that within half a G and within 100 feet accuracy. So again, for this card, you'll say set up, push, and pull as long as our altitude is greater than 1,500 feet above the ground and greater than 50 knots. When on condition, please state. The pilot says on condition. Then you say clear to maneuver. And again, I'm ready with my pencil, looking at the gauges, and I write down my numbers. So as you're going to 0G, I'll try and make sure I write what I saw on the gauge. So the pilot might try to go to 0G, but maybe they go down to half a G, 0.5. And I'll write what my starting altitude was. And then as they pull and I read I see the dial go up to 2Gs, again, I'll write what my altitude is. So I'm reading both what G did I actually see on the gauge with what altitude. And then again, once I have all that information down, I'll say, or the pilot might say, hey, test point's complete. So you know he's done or she's done doing the maneuver. And then you'll say, okay, test point complete once you've written all the numbers down. Next card, card 5, roll characteristics. So this one, it was kind of that example I gave you in the beginning where you have a data band where you're asking the pilot to go minus 45, positive 45 with a plus or minus 5 error. And what you're trying to do here is you will record how long it takes time-wise to go from minus 45 to positive 45. And what I would suggest even for this card, even though it's not stating to do, is to actually try and figure out how much you might have angled. And for that, you could try and do it visually. Just you looking at the horizon and trying to see, does that seem like 45 to 45? But the purpose of this card is later on with your actual cell phone data to see at what angle did you start, what angle did you end, and try to see the total displacement over time to see what your roll rate was. I'm not going to cover again each of these test points now. You should practice again the whole setup roll left -45, and when the pilot says on conditions, clear to maneuver, start timer, right my time, test point complete. And practice with your deck, and also practice shaking yourself or having someone shake your seat or wherever you're standing shaking you, because you'll be in the glider moving around. So you need to be able to read and write this information as you're not sitting comfortably at your desk watching this video, because in the glider it will be going through some dynamic motions, and you'll have to be able to write all this information as you're moving around. So what better way than to practice trying to read it, moving around, having someone move you around to understand how are you going to read the card, and more importantly, how you communicate to the poly behind you. The next card here will be that wings level side slip. That is pretty much just having your aircraft, in this case the glider, come up, and you're putting a rudder input where the pilot is to kind of help you yaw one way to the other. And what you're trying to see is, hey, the aircraft is going straight and forward as it's now trying to kind of turn using its tail, the rudder. Is that causing me to still fly straight into the camera but pointing at another way? Or am I coming in and I yaw and it actually changes the direction of the fly path? So again, this is more of a feel. That's why there's those questions. Did you feel like you were turning? Were you still flying in the original straight line, or are you now flying in the direction of the nose that you're going into? Explain what it all felt. And again, that's just you to kind of get an idea of that. There's no gauge on the glider from what I recall. So we'll be using what you feel in your deck of cards, but then going with the video, synchronizing it with the data acquisition system to see some of that sensor information and understand, hey, you know what? It was pointing this way, but we were flying straight kind of information. The seventh card will be the sync rate. So this is now more of you're flying straight and level. So wings leveled, no roll input or pitch or yaw. It's just wings level, straight flight. And you're just trying to glide through the sky and kind of see how long does it take to change in altitude, to get an idea of, again, if you were just to glide straight at that current condition, how long would it take before you kind of come down to zero altitude above the ground? So in this one, you're asking the pilot to just set up level flight, 50 knots. When he's on condition or she's on condition, say hack, start your stopwatch, and pretty much remember how much each of those ticks are. So in this case, we're just asking you to try and get through 200-foot drop and then write that down. So you'll start your starting altitude. Let's say it was 1,000 feet. Well, you can't, because it's telling you the altitude must be greater than 1,500 feet. So let's say it's 2,000, and 200 feet later, that should be 1,800 feet. So I'll write my end altitude and how long it took to drop 200 feet. And from there, you can calculate, hey, how long would it take to get down to 0 feet, to get an understanding of, again, your sync rate. The eighth card will be the spoiler retraction. It's almost like a speed break in some of these gliders. I'll show you later on the simulator. There's these little bars that stick out on the wings, and it's causing the wind to hit it and kind of slow you down. And for some of these, and what you're just trying to see is, hey, what was my starting altitude, starting speed, and the moment you get those out, what is my end altitude and end speed after about 10 seconds or whatever happens first, either the 10 seconds time or the 200 feet in altitude change. And again, how did that feel as you in the passenger seat as they were putting out the spoilers and then retracting them? So just write that information down. I just found a mistake. I'll fix it in your card deck here because it says it's retracted. Oh, well, it is, because your initial condition is spoiler retracted, but you're going to put out your spoiler to see the effect and then bring it back in. So you see, every single card actually is telling you certain information. Card 9, that'll be your landing card. So this way, so on the first card, you're kind of seeing how long does it take for the toe in front of me to get me up to 4,000 feet. Now this one is, how long does it take us to go about 600 feet to touching the ground? And what's the speed as they're coming in? Are they coming in at a steady state? Are we slowing down? Are we speeding up? How long did it take? And what's your local time? So again, this is one of those cards where based on how each pilot flies, you might see a difference here. And the final card, your ground card. Your ground card is pretty much just letting you know, hey, let's save all the data. Let's make sure we stop the MATLAB mobile and stop the recorder for the video at the same time again, so that it ends at the same time. Not as critical as starting, because in the beginning, if you start one or the other, they're off. But at the end, you might just lose data for the last 5 seconds because your camera was still recording while your MATLAB mobile was off. But again, it's more important to synchronize in the beginning, not so much at the end, but if you do, it just helps. And then saving your file, we'll probably use either flight numbers, saying like flight 1 and count further up. If you want to get a little bit more complicated, you could do like initials. So like, for example, my name is Victor Luquin. So I would do like V Luke number 4, meaning, hey, I know it's me flying and it was the 4th flight. But again, if you just do F1 through F whatever number is your last flight, and you have some type of sheet where people remember what their flights are by writing it on the deck of cards somewhere, then that's good. Because again, there's room on the top to write your name or team number, what glider you're flying. So you can just write a number somewhere on the cover sheet letting you know. Up to you guys. So that is the last card deck. There's nothing else. I hope you guys enjoy the deck that we've created for you. We're trying to get you an experience of different types of maneuvers that we actually use as flight test engineers in the very beginning when we're testing brand new aircraft, to make sure they're stable, they're flying, and when the pilot is actually doing a specific maneuver, it's reacting to it. Again, there are way more complicated cards that we execute as flight test engineers that are sometimes specific to discipline engineers. But again, this is a quick sneak peek into what is it to be a flight test engineer and how to use a card deck as you are soaring through the skies. So stay tuned for the next videos. Again, we'll cover different aspects of it. The next videos will go through each maneuver, showing you how it will get executed by the pilot and how you could use a flight simulator to try and practice executing those maneuvers as the pilot would be doing, and to see what does the simulator tell me how the aircraft will react, and potentially comparing that to your real flight and seeing how off or how accurate it is. So I hope you again enjoyed this video. If you have any questions, leave it in the comment below, and until next time, take care.